Ladies and gentlemen, we have a very special guest tonight, Joseph Postma. Many of you may have heard of him, but he, like I, are one of the top climate deniers, well, on Earth. And we could prove it to you. But before we do that, we want to talk a little bit about who Joseph E. Postma is. And he, in fact, makes the climate denier list. We'll get to that in just a moment. But if you come over to his website, theclimateofsophistry.com, we could read about it. His name, Joseph E. Postma, is the owner and author of The Climate of Sophistry. He has a master's degree in astrophysics, which he received in 2007. He gladly shows his graduate thesis here and here, where you can go look at. And, well, let's just get into this before we meet Joe. He became interested in the climate science debate because he used to believe in anthropogenic global warming and climate change. Well, so did we, Joe. But ultimately, he has scientifically concluded that global warming is an invented scheme for political control via manufactured politics using manufactured science. And, well, Joe, we couldn't agree more. And welcome to the show.
Thanks. Nice to be here. Nice to meet you.
Now, just to get our viewers up to speed on who you are and why you're here, tell us a little bit about your degree in astrophysics, where you got it, and I just gave a synopsis about how you got into the whole climate fraud genre. So could you just give us a little synopsis on those topics?
Well, I'll give you a little bit of my background, my history. I mean, I don't need to get into my master's thesis because that'd be pretty boring, probably for most people. I studied stars, studied variable stars for my master's thesis. But how I got into astronomy in the first place, well, I did my undergrad at the University of Western Ontario, which is in Southern Ontario, London, Ontario. And then I came to Calgary, Alberta to do my master's degree. Now, I grew up, I had a childhood that was, a little bit crazy, a little bit rough. We moved around all over the place. Anyway, don't need to get into details like that. But basically, I really had no direction in life when I was in high school. Didn't know where I was going. Smoked a lot back then. Smoked a lot of cigarettes. So I was out. It was probably when I was 16, 17 years old. I was just out for a walk one night, picking up some smokes from the store, and I looked up at the sky, and I'm like, what is up there? I said to myself, I said, what are these things? What is the word star mean? What is the word solar system? Like, I didn't even know what the heck these words meant. What is a solar system? Like, you hear that's on Star Wars or Star Trek, right? You hear the word solar system. What is that? What's a galaxy? So I went to the library at my my high school library for the first time ever setting foot in the library, and I just picked up a little book on astronomy, and I just thought, holy cow! Like, there's planets out there, there's solar systems out there, there's galaxies. What is it? How come how come everybody isn't talking about this? Right? So anyway, yeah. So anyway, I mean, I was a very poor student. I hated school. Like I passed I passed a total of 6 credits out of my first 16 credits that I was supposed to have in my first 2 years of high school. Like, I just wasn't there. I wasn't paying it. They probably wanted to put me into basic level school or something like that, just because I hated school. Anyway, astronomy got me really interested in math and science, and got me really passionate about learning and being an intellectual. And yeah, I just read more and more books, and then I wanted to read philosophy because I wanted to read what the philosophers had to say about the nature of existence. Because when you get into astronomy, your mind really starts thinking about big questions. Well, why is all this here? I mean, gosh, this is vast. This is vast and amazing. And we're a tiny little species, but gosh, we can understand it all. There must be some relevance to all this. It's just so beautiful, wonderful, and amazing. So I just wanted to keep going. So I, read a lot of popular books, Carl Sagan and the other sort of authors that write books about science. And then, of course, you get introduced into philosophy. So I read philosophy. Anyway, I just sort of developed myself into becoming somewhat of an intellectual. I remember I took a general level physics course because I wanted to start learning the math and, how does gravity work? How do you do the math for that? And my physics teacher is just in a general level physics course. He said, Joe, if you really like this, you could go to university. I looked at him, I said, what's a university? I literally said that. What's a university? He goes, well, it's where people go, to study this stuff, like in the books that you're writing about. And I thought, well, that's neat. Well, a few years later, once I got caught up to my, high school courses and got finished high school and, put myself through advanced level courses, took adult ed on the side to get myself caught up. And then, so anyway, ended up going to university, and that's where I loved it. So it was a really personal story. I really love it. I really love astronomy. It really changed my life. And so I guess maybe you could say in some sense, I'm a real genuine scientist. I really care about actual critical rational thinking. I really came into science from left field and not from a sort of just sort of typical upbringing and entry into it. You know what I mean?
I do, and it's a great story indeed. And if you are a true scientist, then you probably won't get pissed off at some of the questions I may ask you as this interview continues. Now, I have a much deeper, let's say, history with science. So by the time I was 13 years old, I had already discovered all those things that were hit with you when I was younger. And I was so advanced ahead of everyone in grade school and high school. I had already learned about calculus by the time I was 11. And I had already, on my own, learned how to do almost all of that math. So by the time I was in 5th grade, I had nothing to do until I was a senior. So my high school years kind of crashed, and I became a bad person because I had already learned everything they were saying, and it seemed so stupid. It seemed so stupid to me. Now, luckily, I went to college, and I was failing out of college, and I was sitting at the bar in my second year of college, failing out of college, next to this old dude that looked like Santa Claus, and I was just so miserable. And he's like, "What is your problem?" And I was like, I told him, I was like, "Look, I'm spending all this money to get, the big career and make all this money." And he's like, "Well, what's your major?" I said, "International business." And I said, "I hate it." And he said, "Well, what do you like?" And I said, "Well, I love rock climbing, and, I like to go out hiking, and I love rocks." And he's like, "Well, why don't you become a fucking geologist, you idiot?" And I was like, "What do you mean? What is that?" And he's like, "A geologist, this scientist who studies rocks." And I was like, "Yeah. Yes." It like hit me. I was like, "Yeah." And I was like, "Who are you?" And he's like, "I'm the head of the geology department." He just happened to be sitting there at the bar with me.
Oh, wow.
And that was it. And then that was my 3rd semester as an undergrad. And every semester after that, I got a 4.0. And I took high level fluid dynamics, hydrodynamics, thermodynamics. I took mineralogy, crystallography, petrography, stratigraphy, paleontology, and I aced everything all the way until I graduated. I wasn't the top student, Joe. I was like 14th. They had one full scholarship, and I got asked to have that scholarship to graduate school. My mind was blown. And so we have very similar types of things where there's a blossoming effect. And why don't you continue? So you get your inspiration, and you go all the way up through your graduate degree. What gets you into climate denial? I mean, because we are the most hated people on Earth, if you don't know.
Yeah, sure. Well, you go through school and you're just a student, and you generally go along with everything and go along with what you're told. And, you just sort of, originally I believed it. Well, the scientists can't be wrong. The level of critical thinking that any scientist who still just toes that line is almost nil. Like, I had zero critical thinking. It was just something you heard about. Climate science was on the news, or climate alarm was on the news, and apparently it was something that scientists from the university were saying, so good enough. That is the extent of the critical thinking that any remaining scientists who still believe in it are putting into it, right?
Yeah.
I can tell you that. Yeah. That's the extent of critical thinking, which is not at all, obviously, which is not at all. So anyway, what actually happened was I read a book suggested to me by my now wife, the book Michael Crichton's State of Fear. So I read that book, and I thought, well, this has got to be a bunch of bullshit, right? Because it's a good book. If you haven't read it, everyone should read it. It's a fairly decent book. Michael Crichton was a famous denier, right? So anyway, I just went and I looked online, and I just did actually the very first time I did a Google search. And it brought me to, I think that site is Real Climate. It's done by one of these alarmists, by Gavin Schmidt. I think it's called Real Climate. And so I looked at their FAQ and I read the FAQ of what how they respond to deniers, and I thought, well, that's obviously a bunch of BS. Like their answers were sophistry. Like it was clear that their answers weren't addressing the scientific concerns. So anyway, so I just started looking into it more and more and more, and then I got connected with outfits of skeptic groups, and so it really just blossomed until well, quickly, very early on, I discovered what the problem was and what the basis of the fraud, the error was, and it's so obvious and so simple. You would think that scientists would want to talk about it and would want to discuss it, but what you find is that there is a what's it called, a firewall blocking any sort of critical analysis from making it into the mainstream. And so this is some form of conspiracy or something going on. Partially, you just have a bunch of morons who won't think critically about it. On the other hand, I don't know, it's some sort of religion. It's become a religion. It seems to replace the need for original sin. I wrote that on my blog once a long time ago. Religious people, Christianity, typically we're, European descendant, we're all typically, have Christianity somehow in our heritage. Anyway, there's this idea of original sin, and the atheists seem to really want to use that or fulfill that archetype psychologically or emotionally with this idea of climate alarm, that your presence, breathing and exhaling carbon dioxide is bad and toxic for the environment. So they really seem to just get emotional, spiritual fulfillment from this concept for some reason.
Yeah, well, I mean, it's our position on the channel that the main purpose is twofold. The first one, and this comes out of the Club of Rome, is to use a deceptive idea that everyone will gobble up, and we can blame it on society, and then we can control the narrative. So they're simply using it to control policy, to control taxation, and to take things away and freedoms from people living on Earth. All at the same time. They're doing that by pushing fear, making people sick, and making you feel guilty about, like, listen, if you really are a critical thinker and you watch what every single human throws out in the wrappers they're opening up all day, all of that is what's killing our Earth. It has nothing to do with CO2. CO2, if you just dive into it for a 6-hour escapade into research, you're going to find out CO2 is the lifeblood of our planet. And without CO2, nothing is here. It's actually what greens our planet. And
I call it the life.
Go ahead.
Yeah, I call it the life molecule. It's the life molecule. It's literally the molecule that makes life. It's literally how DNA gets made. DNA is carbon based. Carbon dioxide is how carbon gets into the biosphere. Carbon does not come from the ground to make DNA. It comes from carbon dioxide to make DNA through photosynthesis, and then we all eat that, right?
Absolutely.
From phytoplankton up, right?
Well, and more importantly,
carbon dioxide.
Geologically speaking, we're at one of the lowest CO2 concentrations in geologic history. If we were to just drop down 50% of our current
in evolutionary history,
yeah, we're dead. If we just cut CO2 in half, we're dead.
That's right. Yeah, exactly. That's right. Yeah, if you cut CO2 in half, photosynthesis stops, and yeah, that's a permanent extinction. And so you really have to wonder, like, what's happening psychologically to people when, like, archetypally on a sort of subconscious level, when the mass of the world, like the masses of people of the world, are being told to hate carbon dioxide, or being told that carbon dioxide is a pollutant and that is bad for life and bad for the environment, when it is the base molecule of the whole biosphere. It's it's making people crazy. That is just such an anti-existence, anti-life belief to have. It's not going to lead anywhere good. I did see an article recently, about a year ago, where apparently some Israeli scientists are trying to develop a new bacteria. They're trying to genetically engineer a bacteria that they can release into the wild, and it will just eat all the carbon dioxide out of the air, because they think that this is a good thing to do. Because wouldn't the environment be a lot better for life if we take all the carbon dioxide out of the air with a bacteria that we release into it that replicates exponentially until it's, like in a petri dish, consumed all the CO2 out of the air?
Well,
I mean, do you see how psychotic this is? This is gonna be a final like extinction level event.
It sounds like the manifestation of the Georgia Guidestones. I mean, if you know anything about anything, you know that
this is going to go way beyond. This is going to go way beyond that.
Well, of course, because if you kill the biome, then we're all dead. It's a circular downward spiral.
Yeah.
Now, real quick, I want to get to some crazy questions that you may or may not agree with.
Mm-hmm.
Now, first, I want to premise this by saying that in 1927, the Big Bang hypothesis was created by a Roman Catholic priest. And then it was taken up by some astrophysicists between 1930 and 1940 when the final hypothesis was made. And now everyone just believes the Big Bang to be this glorious golden rule. Based on all research that you could ever do, the Big Bang is a total fantasy. And that includes dark matter and dark energy. And if you actually learn the math, which it's hard because mathematicians don't talk to physicists, and physicists don't talk to chemists, and chemists don't talk to astrophysicists. And so there's this, this compartmentalization of information. But any of the top mathematicians, because I know them, will say that there can't be dark energy, and there can't be dark matter, and there can't be black holes, and there can't be a Big Bang based on all of the observations we're making. I'm just interested in what your position is on all of those 5 controversial topics: the Big Bang, black holes, dark energy, dark matter, and let's just go with those 4. Do you believe in them?
Okay, those.
Are you on the fence? Where are you at?
No, I think I accept I accept the current status of those. I think the Big Bang is I don't know of any other explanation which would satisfy, the observations of the cosmic microwave background and, the redshift and the expansion of the universe, and the accelerating expansion the farther you look out. So I don't know. I think it's a reasonable explanation for now till I see anything different. Well, so yeah, I do subscribe to the Big Bang. As far as
let's get back. Let's
dark
get to
matter,
the Big Bang.
Dark energy.
Let's get to the Big Bang. Let's just discuss that. Red shift and blue shift, that's all been disproven as having nothing to do with acceleration or distance. Are you up on those current peer-reviewed papers?
I'm not up on those, no.
Okay, so if you could just discount redshift as being bullshit, and the cosmic background radiation that is all accepted, there are hundreds of papers that are calling that out as nonsense. And simply because the first gravity wave ever detected was determined to be wasps nesting in the detector itself. So there are lots of problems with the current state of with astrophysics. So let's get to what your thoughts are on dark energy or dark matter, which, by the way, has to be almost everything.
Right. So dark matter, comes out of the rotation of the galaxies, and also from gravitational lensing. So there seems to be some effect there that there's no explanation for. So it's called dark matter. Dark energy, similar analysis generates dark energy. It's basically just saying we don't know what it is, or they don't know what it is.
Right.
So it's just called dark because they don't know what it is. Yeah.
And so $40 billion in decades of studies in thousands of peer-reviewed papers with tens of thousands of authors have all concluded that they can't find any of it. And here's the problem. Words like gravitational lensing are complete fairy tales made up to explain that they're complete fucking idiots and that they have no idea what they're talking about, that they're gobbling up this money, hundreds of scientists on a single paper to say we didn't find anything. And the point is that the more and more we get better actual telescopes up there to see, what we're seeing is missing dust. And there's so much dust in these stellar systems that almost 90% of the missing matter can be found in the missing dust that we couldn't see. But now we can see it. So, but no one is willing to say that there's no such thing as dark energy and dark matter. We just didn't see the dust. And all the matter is there.
Yeah.
And it simply has to do with ego, funding, and the state of the bullshit narrative. Now, one other thing I can tell you is that there are dozens of scientists, Joe, that can prove that the universe is infinite and it proves all the math on all the stellar objects. The moment you bring into Big Bang, you have to create bullshit things like dark energy and dark matter and redshift to create the fake notion that everything is moving away. But when you actually observe it and do real science, equal amount of objects are moving forward as they're moving away, which is not could not be the case in the Big Bang model, unless you happen to be at like some exact location where that's happening. But the more and more we look, there are just equal amount of objects moving away as they're moving towards us. And when you look at some of the three-dimensional modeling of like our local region of the universe, I'm sure you've seen some of those. They came out within the last decade. That there is more of an amorphous feel, a fractal nature to the universe. And what are your thoughts on potentially the universe being an infinite entity that has no beginning or end and has just unimaginable to humans, like what that means?
Well, I think if you consider the concept of existence, first of all, so existence itself has to be infinite and eternal. Existence itself is uncreated. Existence has to be in a state of, permanent, perpetual existence. So existence itself has always existed. But existence itself, would potentially be separate from the current universe we inhabit. So the current universe we inhabit may be some sort of iteration or some sort of creation, some sort of playground or whatever it is that you want to call it. But this universe, would be possibly a temporary construct within this general concept we would call existence.
And you think that that's a finite construct that had a big bang, a beginning? Because that doesn't make any sense in that.
It could be, yeah.
That idea. So our existence is
infinite. It could be, yeah. So the
universe,
the Big Bang could be, yeah.
So we're infinitely alive in a finite.
Yeah, that's
universe.
Right. Yeah.
That's exactly opposite of what I believe.
Yeah. So. Right. So you go ahead. So explain your position then.
Well, I mean, we all know biological entities are quite finite. We have a very limited term, a life term. But what is the biological entity? What is the soul? I mean, we could have a whole podcast on that whole concept. Yeah. I think that the human biological brain is an adaptation, is an antenna that is tuning into the soul, which is what each individual has. So I think that you're on the right path.
Well, the soul uses that. Yeah, that's right. So I subscribe. Yeah, so I subscribe to more or less to Leibniz's monadology theory on the nature of existence and the soul. So yeah, that's right. So our bodies are temporary constructs that our souls are tapped into, jacked into, and yeah, that's right. They use the brain for interacting in this world and for thinking in this world and whatnot. So
okay, all right.
So yeah, so the soul is existence. So the soul corresponds with base existence. So it's something that's eternal and has always existed and will always exist. But this universe that we are experiencing now is a temporary construct. Eventually, all possibilities of life, of behavior will be explored, and the soul will eventually get bored of this place. And if you accept the current cosmological consideration in science of this universe, well, but I was just going to say, if you do, then this universe does apparently have a finite lifetime, because eventually the rate of expansion would grow so rapid that matter wouldn't be able to form anymore, basically, and so the universe would have a finite lifetime under the current model. And then, of course, it has a beginning as well. But that's not the beginning of existence. That's just the beginning of this current game.
I don't know if you've seen any of the headlines about the Roman Catholic Church, but anything coming out from that facility is probably not worthy of a second. So let's just jump into the last topic I threw out there, black holes, and then we'll get to your books. What are your thoughts on black holes? Because let me premise this. Because black holes recently, in the last 5 years, we have over a dozen papers coming out. Black holes, which are now visible, and they're now emitting shit. Those are two rules that go against black holes. So black holes no longer just take everything in and no light escapes, but now light escapes black holes, matter is shooting out of them, and jets, and we can see them. All right, go.
Well, it's not. Yeah. So the matter and the light is not coming out from within the event horizon itself. It's something that's happening just outside due to interactions, uh, disk spirals of matter, and the sort of toroidal energy fields and high temperatures that are created from that. As far as the black holes go, uh, you look at the motion of stars around the centers of galaxies, and using the equations for planetary motion, or for gravitation, and for planetary motion. What do you call that? Orbital motion, the orbital mechanics, the equations for orbital mechanics. You can easily calculate what the mass of these objects have to be. So the mass simply comes out to very, very large masses. So the question is, what can be 100 million stellar masses or solar masses? What can weigh 100 million times, or what has the mass of 100 million times of that of the sun, but you can't really see it? It doesn't look like a sun, but there's other stars. So that's all a black hole is, right? Something is there.
Well, that's also what
seems to have a mass of 100 million suns.
That's another fairy tale.
But
neutron star is a black hole you can see, right? Another fairy tale.
Right. Well, a neutron star collapses, right, after a certain amount of mass.
No, it doesn't. That's a theory.
Then
you're speaking
the
about
neutron
it like we
repulsion
know
breaks
that.
down.
You're speaking about
sure.
it. It's bullshit. It's made
up.
Well,
of course, that's a theory.
Yeah. All right. So, have you ever heard of?
In astronomy, everything is
plasma?
theoretical.
Have you ever heard of plasma cosmology? Have you ever heard of Anthony Peratt? Because if you just look into what's gone on in the last decade, the solar Z-pinch and Berkeley currents can experience all these phenomenon without the use of black holes and dark energy. It's everything we observe in the universe can be explained using plasma cosmology, not fairy tale science, neutron stars, dark energy, blazars and quasars, and every other fucking fairy tale word we could make up. That is what astronomy and astrophysics is. It's fairy tales. And not a single person has the balls to actually say, maybe we need to change everything, because we've been wrong 95% of the time. You know what's happened, Joe, in the last 20 years as far as cosmology is concerned and astrophysics? Every single article in the mainstream that reports on new discoveries says, what does it say, Joe? It says astronomers are baffled. Astrophysicists are baffled. That's how they all begin, because their model is wrong,
they love to say that.
period. What are your thoughts?
Yeah, I don't go that far. I think that for the most part,
you still want a job.
Astronomers astronomers are interested in what's out there, right? And you have to make inferences, and of course, nobody can actually go and observe. It's an observational science, but it's remote detection. So you still have you still have to.
Webb is about to launch.
So you still have to infer what you're looking at.
That are completely wrong using the current models, and they're wrong every time. Why are they wrong? If you're wrong every time, Joe,
well, you have to interpret
you're a scientist.
If
you're wrong every time, what's wrong? The model's wrong. Do you agree on that?
I agree with that idea. Yeah, certainly. I agree to that concept that you just explained, but I think that it applies more so to climate science, where we're going to be going next here.
All right, let's jump over to climate science. And real quick, we'll tell them about your book. So let me pop this up on the screen. Where is it? Here it is. In the Cold Light of Day, Flat Earth and Modern Physics and Numerical Proof for God, a climate alarm story. This is the full paperback here, and you can grab that. And Joe just came out with a shorter version here on Kindle for only $5.99, The Layman's Guide to the Greatest Scientific Fraud in History. Awesome. So I love the titles. Run us through what does the book say? Why should we go get it?
Because if you read the short book, the second book, I mean, it'll stun you. What you read will stun you if you're paying attention. Like if you have an independent mind, like obviously, David, clearly you have an independent mind. You are ready to call out bullshit when you think you see it, right?
Yes, sir.
So I think for most people,
that's my job.
Except for you. Like I know that you get this. I can, yeah, for sure, absolutely. But I mean, for most people, it's hard to accept. It's just stunning the degree of fraud that has occurred in climate science and what they're doing with it politically. From my perspective, astronomy isn't a political science. It doesn't really have much political influence. Climate change, on the other hand, that's all about government, all about control, all about politics. Yeah. But you'd be sort of stunned. You will be amazed at the degree of fraud which has occurred. And it's so easy to prove. It's trivial. It's trivially easy to prove. It's trivially easy to demonstrate. Children can understand it. When my daughter was in kindergarten, I told her about it, and she was like, wow, that's pretty crazy that people think that, but that's what happened, Um, mhm, yeah. Mhm, mhm. Oh, nice. Yeah. Mhm. Yeah, absolutely. I agree with all that. Yeah, that's a very, very good summary. Excellent. Here, and we might need to pause here.
All right, we're back with our special guest, Joseph Postma, and we're going to just finish up this podcast tonight because we have so much to talk about that we'll just continue it next time. Now, this is a teaser for where we go from here, Joe, so break it down.
So here, this is what people got to see. This is the foundation of climate science, right? So I was taught this in my own undergraduate course in astrophysics and planetary science. So I had a course called planetary physics. In second year undergrad, in my astrophysics degree, we have a course called this, and this is what you learned. This is what I learned, identical to these diagrams in my classroom. And I'm showing you examples here from all sorts of different universities. So what's being done in these diagrams? What is the shape of the Earth? See this shape here? What do you call that shape, David? What do you call it?
That is a line.
You call it that's a line, yes, and it represents a surface. So it's actually what kind of shape would that be? That'd be called a plane, right?
A plane. That's not.
It's a flat surface.
Yeah, not a shape.
It's a literally, yeah. All right. So it might seem like it's not a big deal, but it is actually a big deal because what these diagrams are showing, what the foundation of climate science is doing, is saying that what you can do with the sun is average the sun over the entire surface of the Earth at once, coming into the Earth, as if the Earth is a flat plane, and that this is a legitimate approximation for solar heating. Now,
Well,
what do you think? Do you think that's a legitimate approximation for
well,
solar heat,
that's not what
for
they do.
solar
They
sunshine?
take
Is
in
that
the
approximately
no.
how?
I'm a solar expert and a solar scientist in my spare time. And what they do is they take the total solar irradiance coming in, which is around 1374, and they divide it by 4 to get a number which is a quarter of that,
Yeah.
which it would be representative of the
Yeah.
the total watts per square meter hitting a sphere. So you have to divide by 4 to get the spherical nature of the Earth. If you keep it as the full value, then you would be talking about a flat Earth. So in flat Earth, you would use the full value 1374 watts per square meter. But in a spherical Earth, you have to divide by 4 to account for the total solar irradiance on a sphere, because it would be a quarter of that.
Okay, now this is very important, all right? Does the solar input come over the entire sphere of the Earth? Is that what happens with solar input?
Well, now you're talking physics, because if you're talking about a point on the Earth, you're not on that single point. You would not be experiencing 1,374 watts per square meter, because the actual point would be on a curvature. So it would be a displacement of that.
Right. So what?
I mean,
So we don't need to talk about a point. We're talking about the whole Earth. Like the whole Earth, take a snapshot of the Earth, a 1 second snapshot, because the units for that 1,370 that you referenced as units of per second. Yeah.
Yeah.
So in a per second snapshot, is sun falling averaged over the entire surface of the Earth?
No. And the reason is because only half of the Earth are getting the input, and half of it is lit up. And so you can't just divide it by half.
That's right.
Half of it is also curved, and you have a half of a sphere, so it's less than that, which is why the value is 4. So they divide the total value, 1374, by 4 to get the TSI on the illuminated side of the Earth at that moment. That's the assumption.
No, the over 4 is spreading it over the entire surface of the Earth.
Well, Joe, what I'm trying to explain
that spreads
to the
it over the
layman
entire
is that
surface
on
of
the other side of the Earth, there's very little input from the sun when it's not hitting, because it gets cold at night. You know that, right?
Well, yes.
And then the exact perpendicular.
I agree that the layman understands that there's a day side and a light side, or a day side and a night side, right?
The
so the layman understands that
spot
for sure.
directly facing the Earth, I'll give it 1374 watts per square meter at that spot, but it's only in one spot. So you have to average it over the whole sphere somehow.
Yeah. And then right. But does the sunlight input average over the entire sphere? Is that what the sunlight is doing? Like in terms of physics, is that what sunlight is doing? Is it averaging over the entire sphere as an input?
Well, climate science is flawed in so many ways, because they don't.
I mean, it's obvious.
They don't account for water vapor.
The answer is obvious. The answer is obvious. Obviously not, right?
Obviously not what?
Yeah, sure. I mean, obviously, well, the answer is obvious, right? Obviously, the sunlight does not input over the entire surface area of the Earth at once, right? But that is what these diagrams are showing. They're showing sunlight inputting over the entire surface area of the Earth at once as an input. So with a flat plane, as if the Earth is a flat plane with no day and night, with a completely uniform distribution of solar energy at 1/4 of its power.
Well,
in order to get that average
for the dark side of the Earth,
averaging the input. That's right. Yeah. So should you average sunlight over into the dark side of the Earth as if this is where a quarter or a half of the sunlight is falling, and then reduce the intensity of the sunlight on the light side by a factor of 2 or 4 in order to do that in your mathematical model? Does it make sense to do that?
No, none of their mathematical models make any sense. And in fact, if you look at CMIP 3 through 5, they are 95% inaccurate, which means that all of the billions of dollars of funding into climate science have only accounted for 5% of any of the actual data that we've gotten. So all of the models are 5% correct, which is, I mean, you and I could do better on a napkin, creating thermodynamics with French fries. I mean, it's just such bad work.
Yeah, absolutely.
Something has to be going on there.
No, absolutely. So the foundation in climate science so if you compute, what is that value? The solar intensity, that's what this is. Can you see the cursor moving? Anyway, this divide by 4 value, what they've done with solar intensity is that numerically that reduces down to a temperature of minus 18 degrees Celsius. So what they're doing is they're treating the solar heating power of sunlight on the Earth as only minus 18 degrees Celsius. So in their model, in their foundational model for understanding the climate, their sun being averaged over the entire surface area of the whole Earth only has a power to heat things to minus 18 degrees Celsius. So that's their starting position of understanding the climate, as shown in all these diagrams, and as I attest that I was taught myself as well
And
in
you've got Penn
university.
State University.
So their
up
solar
there.
power,
I mean,
because they're
that's the man hockey stick down there.
Yeah. Yeah, that's right. Yeah, for sure. Yeah. So that's their starting position. So the sun cannot create the climate because of the solar power with only minus 18 degrees Celsius. Is the sun going to create the climate? Well, no, it can't even melt ice, right? At that heating potential. Minus 18 degrees Celsius is very cold, right? So they come up with this greenhouse effect instead to pump up the heat, right? So it's no longer the sun that you feel heating you in the day. I mean, this is literally what is in their math. It's not the sun that heats you in the day. It's the air that heats you. And if you work out the numbers, actually, the numbers are worked out in this peer-reviewed publication. If you zoom in on it, the number is that the atmosphere sends twice the amount of heat to the Earth than the sun does. Of course, the sun is a source of energy, a source of heat undergoing fusion. The atmosphere is just a passive gas, so there's no real source of energy in the atmosphere to be heat. Notwithstanding that the atmosphere is colder than the surface, so it actually has no heat to send to the surface in any case. But in their accounting, in their peer-reviewed literature, the cold atmosphere provides twice the amount of heat to the climate, or to generate the climate, than what the sun is creating. So, and they have to scheme that sort of extrapolation in their math because they've started with a sun that's only minus 18 degrees Celsius and can't create the climate. So that's what's happening at the foundation of climate science, and that's why the rest of it is such junk science, okay? So here would be a different way to demonstrate it, with sunlight falling over on a hemisphere, because that is how sunlight actually falls on the Earth.
Yes.
It falls on a hemisphere,
yes,
and as you were indicating, with an intensity distribution of maximum directly into the zenith, going to 0 around the terminator. Yes, right? So if you do that, now you have very hot sunshine. And the temperature of sunshine around the equator is actually almost 120 degrees Celsius. So the sun is very, very hot, very powerful. The sun can create the climate directly if you start with a model of the Earth-Sun interaction with a spherical Earth, then you find that, wow, sunlight has an intensity great enough to create the climate all by itself. You don't get that with their model. So that's an amazing, important difference. Yes?
Yeah, and you could prove this if you go outside with a lens when the sun is out and burn shit. Because that's the same thing the atmosphere is doing when the sun hits
That's
in.
right.
It's heating the Earth. And we all know
Exactly.
that the sun heats the Earth during the day, and when it sets, it gets cold out. And so I guess we have to get climate scientists up to speed on our level of thinking. What say you?
Well, I mean, this is really basic thinking. This should be basic science. This should be really basic, easy stuff to understand. Yeah.
Yeah.
But I mean, I present this, and I present this comparison to climate scientists and to other physicists and astronomers who believe in climate alarmism, and they refuse to consider it. So I'll just say to them, I'll say, guys, we're astronomers here. We understand orbital mechanics. We understand that Earth is spherical. We understand that sunshine is hot. Yes. So now, if we have a model, a flat Earth model, which by its mathematics necessitates that we make the solar input 1/4 of its intensity, which makes it minus 18 degrees Celsius, which makes the sun unable to create the climate. So then we got to create some other mechanism to get the climate created, since the climate can't create it. So let's have that model on one side. Now on the other side, let's have a spherical Earth model where, you don't have to do anything adjusting, reducing the solar intensity. You just use the solar intensity as it actually is on a sphere. Then you get this intensity distribution where sunlight is very, very hot around the equator, just like you can experience if you've ever traveled around there. Even if you live in more northerly latitudes, you can go outside, you can feel that sun is very hot. You can see the cumulonimbus clouds being created in real time by this high intensity, high heat sunshine. So which model is better? And they just say, well, that would not be good for the climate alarm narrative, and we got to do it because it's good for the world. And so they're going to stay with flat earth theory. They literally say that to me. That's literally what happens.
Well, they don't say flat earth theory, but that's what they mean.
Well,
Guys,
that's what they mean. They want to admit that that's what it is. Yeah.
guys, you can check out Joe Postma on Twitter. You can check out his book. We'll leave you links below to all this. His website is the Climate of Sophistry, and we'll leave you links to that too. Joe, we're going to have you back on the show to discuss more about your book and your theory about flat Earth. Well, no, you don't think the Earth is flat, right?
Oh, of course. I'm telling them not to use flat Earth theory for understanding the climate.
And that's why all these flat Earthers
no,
are
literally. So,
popping
guys,
up.
that's the fraud. I know. So, guys, that's the fraud. We have flat Earth in modern physics. Flat Earth has been clandestinely inserted into modern physics through this political fraud. It's brilliant. Whoever came up with this is freaking brilliant. They got like it's a joke. Someone is making fun of human science and being like, "Hey, look what we can do to these guys. Watch this. Hold my beer." They're like, "Watch this." And somehow somebody inserted flat Earth into the heart of modern physics. That's what it is. It's just as simple as it is. It sounds so ridiculous to say, and it's like, oh my God, that guy's crazy. But it's like, I showed you the diagrams. I'm telling you, I went to school. I learned the same diagram at the time. I thought that was fine. Now looking at it more, it's like, wait a minute, that's not fine. You can't say that the sun is only minus 18 degrees heating because that's ridiculous. That can't create the climate. Oh, wait, if you use a sphere, the sun can create a climate. Hey, guys, don't you think that's important? And now nobody wants to talk about it because it's so politically taboo to say anything against climate science. No professor, tenured professor, even though they have tenure and they can do whatever they want, they still won't speak out against climate science when it's just such obvious fraud. So anyway, that is the scale of the fraud. It's such an amazing fraud. We have flat Earth and climate science. And so, David, to you earlier, you were going on, challenging me on things in astronomy. Yeah, at this point, I don't blame people for just wanting to say, you know what, let's take the whole baby in the bathwater and just throw it out. Because, guys, we do have flat Earth in modern physics. Modern physicists, modern astronomers, you can show them that diagram that I just showed you, that comparison, and they won't do it. They won't agree to it. They won't look at it. They won't agree that it makes a difference. So we have at the highest levels flat Earth in modern physics. So if that's what our supposed intellectuals are doing and have done, can you really trust what else is going on? Can you really? No, you really can't. You really can't. As far as me being an astronomer, I still want to think that, okay, yeah, black holes, I can see why they're saying that. But on the other hand, the scale of having flat Earth in modern physics is so bad. Like, that's just so bad. That's so bad. You can go right ahead and go right over to what David is saying and just say, let's just package this all up and we're just going to throw it all away. And we're going to start over again, because whatever you people think you have done up to now, yeah, we're going to forget about that now because you guys are ridiculous, right?
You want to hear more from Joe? Check out the Climate of Sophistry. He has a bunch of stuff over here. We got a bunch of videos up here. There's dozens of them, including some rehashes of what he just talked about moments ago. Come subscribe to his YouTube channel, and let's get this up above 3,000 before Joe gets back on the show. Always a pleasure, Mr. Postma. First time we had you on. Parting words.
I won't go into another rant. My rant was probably good enough. Thanks everybody for listening, and yeah, nice to see you all.
Okay, awesome show. Thanks, Joe, and we'll see you soon. That's a boom.